So at t equal to minus 3, so dy by dx will be, so we'll get 3 into 9 minus 9 by 2 into minus 3 varum. So that is 18 by minus 6. So we'll get minus 3. So therefore the equation of tangent line will be y minus 0 equal to minus 3 into x minus 9. So that is y equal to minus 3 into x minus 9. So this is the equation of the second tangent line. So the two tangents will be y equal to 3 x minus 9 and y equal to minus 3 x minus 9. And now let us look at an expression for arc length of parametric curves. So if you have a parametric curve, so let us see how do we find the arc length using integrals. So when you take the parametric curve and when you find the arc length, so we take our curve such that, so we have the parametric representation x equal to f of t and y equal to g of t in the interval a less than or equal to t less than or equal to b. So in this interval, the curve must be traced exactly once. Curve more than once trace ചെയ്യാൻ പാടില്ല. So when you find the arc length, so we take curves such that the curve is traced exactly once in the given interval. So let us look at the expression for finding the arc length. So if no segment of the curve represented by the parametric equations x equal to x of t, y equal to y of t, where a less than or equal to p less than or equal to b is traced more than once as t increases from a to b, and if dx by dt and dy by dt are continuous for a less than or equal to t less than or equal to b, then the arc length L is given by, so L will be integral a to b root of x dash of t whole square plus y dash of t whole square dt. So this is the expression for arc length of a parametric curve. So let us look at few problems on finding the arc length. So the first problem is find the circumference of a circle of radius a in parametric form. So the equation of circle in parametric form is, so that is x equal to, so here the radius is a, so here you will have x equal to cos t and y equal to a sin t. So x is a cos t and y equal to a sin t, and the circle is traced exactly once, so we will have 0 less than or equal to t less than or equal to 2 pi. Now x dash of t will be minus a sin t and y dash of t will be a cos t. So therefore L will be equal to integral 0 to 2 pi root of minus a sin t whole square plus a cos t whole square dt. So that is b equal to integral 0 to 2 pi. So we'll get a square sine square t plus a square cos square t. So that will be a into root of 1 varum. Kanam sine square plus cos square is equal to 1. So the value will be a, and a will come outside of the integral. Integral value is t from 0 to 2 pi. So therefore we will get the value of L to be equal to 2 pi a. So therefore the circumference will be equal to 2 pi for a circle of radius a. And let us look at another problem. So find the exact arc length of the following curves. So first we have x equal to t square and y equal to t cube by 3, where you have 0 less than or equal to t less than or equal to 1. So when you take dx by dt is 2t and dy by dt is t square. Okay, so L will be equal to integral 0 to 1 root of 2t whole square plus t square ആണ് വരുന്നത്. അപ്പോൾ t square whole square dt. So that is integral 0 to 1 root of 4 t square plus t raised to 4 dt. So that is integral 0 to 1. So t square will go out of the integral. അപ്പോൾ t വരും പുറത്ത്. So 4 plus t square dt. So let us use substitution. So put u equal to 4 plus t square. So du will be 2t dt, and u will vary from 4 to 5. So this is integral 4 to 5. T dt becomes du by 2. Either root u varum. So that is u raised to 3 by 2 by 3 by 2 into 2 from 4 to 5. So 2 will cancel off. So we will be getting 5 raised to 3 by 2 minus 4 raised to 3 by 2 by 3. So that is the required arc length. And next example, if you have x equal to say sin t plus cos t and y equal to sin t minus cos t in the interval 0 less than or equal to t less than or equal to pi. So let us look at what will be the arc length. So dx by dt will be cos t minus sin t. dy by dt will be cos t plus sin t varum. So arc length will be integral 0 to pi root of cos t minus sin t whole square plus cos t plus sin t whole square dt varum. So expand the terms inside. So we'll get cos square t minus 2 sin t cos t plus sin square t plus cos square t plus 2 sin t cos t plus sin square t dt. അപ്പോൾ 2 sin t cos t cancel ആവും. ബാക്കി വരുന്ന integral 0 to pi root 2 dt വരും. So that will be root 2t from 0 to pi. So arc length will be pi root 2. So that is the required value of arc length. So these are a few things we have learned about the parametric curve. Parametric curve il nammal kandathu parametric curve endana, then how to find the Cartesian equation from the parametric form, then we have seen how to find the slope in parametric form, how to find the derivatives in parametric form without eliminating the parameter, and then we have seen how to find the vertical and horizontal tangent lines, and then we have seen how to find the arc length of a parametric curve. അപ്പോൾ നമ്മൾ ഇതെല്ലാം ചെയ്തത് നമുക്ക് ഇനി നമ്മൾ അടുത്ത ക്ലാസ്സിൽ പോളാർ റെപ്രസെൻറ്റേഷൻ കാണാൻ പോവാണ്. ഓക്കെ, അപ്പോൾ വിൽ എക്സ്റ്റെൻഡ് ഓൾ ദിസ് തിങ്സ് ഇൻ ടേംസ് ഓഫ് ദി പോളാർ കോർഡിനേറ്റ്സ്. സോ ഇറ്റ് ഈസ് ഓൾസോ അനദർ റെപ്രസെൻറ്റേഷൻ ഓഫ് യുവർ ഫങ്ഷൻ. അപ്പം നമ്മൾ പോളാർ റെപ്രസെൻറ്റേഷൻ ചെയ്യുമ്പോൾ വിൽ ബി യൂസിങ് the parameterization x equal to r cos theta and y equal to r sin theta. So all these things we will see under that particular parameterization. So we will begin the polar coordinates in the